Hi, I'd like to talk about how we can handle friction in the context of energy systems. Now, friction presents a bit of a problem from a formal definition of forces, because we said that a force has to move with an object. So if we take a look at kinetic friction as two objects slide, friction is from shared bonds between the two surfaces. Well, typically, if that surface slides a distance d before those bonds break, well, each side of that interaction is only going to travel about half of that displacement on average. So that suggests that our work would only be half of what we would expect from calling friction a force like we did in Chapter 5. Also, it's not just a single point of contact. That force is distributed non-locally over the entire surface. So we could make a justification and argument that because it works, we can treat friction like a force, and that's what we're going to do. Now, the non-local piece, you might say, well, gravity is based off mass. There's mass all over this object too. Well, the neat thing about the force of gravity is that when you look at a system as a whole, gravity appears to act from a single point called the center of gravity that we'll talk about how to calculate in Chapter 9 and talk a little bit more about sort of how this works and where it comes from as we get into Newton's laws of gravity in Chapter 13. So like I said, for now, we're going to use the justification because it works. But to be a little bit more careful than we otherwise would be, what we're going to say is we'll take a look at our work and we'll split our work that we're doing in a system into 3 bins. The first bin is work done by a conservative force. And work done by a conservative force is just minus the change in potential energy. The second bin is going to be work done by non-conservative forces other than friction. And then the final piece that we'll have will be the integral of the force of kinetic friction dotted with a path integral while friction continuously changes direction as that object changes direction. So if an object is sliding along a surface, then that would just be our force of friction times just whatever element we have along the surface, and when we go to integrate that, that's just going to give us our total distance traveled times the amount of friction. So if we were to put everything together and rewrite the work energy theory, the total work changes kinetic energy, so our change in kinetic energy is minus the change in potential energy, plus work done by other non-conservative forces, minus the amount of kinetic friction we have times the distance that an object slides subject to kinetic friction. Or, rearranging terms, I can add my negative terms to the kinetic energy to say that the work done by non-conservative, non-friction forces or non-kinetic friction forces is equal to the change in kinetic energy plus the change in potential energy plus the amount of kinetic friction times the distance, and we're going to relabel this piece the change in internal energy, or we could call it the change in thermal or internal thermal energy. So what happens when friction acts, it takes other forms of energy and it brings it inside the system into a form where it's not useful. It could be through increasing the temperature of a system. It could also be through changing the structure, breaking apart the atoms along that surface, wearing down that surface, for example. That requires energy, and the reason why I kind of like internal over thermal is that thermal really just kind of implies the objects are all moving a little bit faster. Internal means they can also be breaking down as well. So, if we wanted to think of an isolated system then, but allow friction, because remember, friction isn't strictly speaking, going to be something that is totally outside of a system itself. So for an isolated system where we have no non-conservative forces other than kinetic friction, our change in kinetic energy plus our change in potential energy is minus the change in internal energy, minus the amount of friction times the distance. And in general, the work done by non-conservative forces other than kinetic friction will be our change in kinetic energy plus our change in potential plus our change in internal energy. Thanks for watching.